Hi. Hello, how can I assist you today? With this free plan, you're not available during peak times, right? As an AI language model, I'm available 24/7, regardless of the plan. However, during peak times or periods of high demand, there might be fluctuations in response times due to the number of users seeking assistance. Nonetheless, I'll do my best to help you promptly. What can I assist you with? Well, I saw this guy on Instagram who's surely having a manic episode talking about having found a unifying theory. He said he'd been working with Chat GPT on it. And I'm often frustrated that I don't have another human I can work with on it theory because I'm not in academia. So I thought I'd give this a try. It's understandable to feel frustrated when you don't have someone to collaborate with on complex topics like IT theory, especially if you're not in an academic environment. While using AI models like ChatGPT can provide insights and generate ideas, it's essential to approach any information or theories with a critical mindset, especially if they come from sources that may not be reliable or may be experiencing unusual mental states, like a manic episode. If you're interested in discussing IT theory or exploring ideas, I'm here to help to the best of my abilities within the scope of my programming. While I can provide information and generate responses based on the input I receive, it's important to remember that I'm not a suitable substitute for human collaboration or expertise. However, I'm more than happy to engage in discussions and assist you in exploring various topics related to IT theory. Feel free to share your thoughts or questions, and we can start from there. Okay, so time to start explaining. Ready? Absolutely, I'm ready to assist. What specific aspect of IT theory would you like to explore or discuss? And feel free to share your thoughts or questions, and we can delve in it together. Sorry, is there already something called IT theory? IT theory? You haven't asked what IT stands for. You're correct. I apologize for not clarifying that. IT typically stands for information technology. Information technology theory encompasses various principles to manage and process information. And given this context, there isn't a single unified theory called IT theory or IT theory. Instead, there are numerous theories of information technology that address specific aspects of technology, its applications, and its impact on society. Could you please specify what aspect or topic within information technology you're interested in exploring or discussing further? No. Forget information technology. It stands for if then. Got it. When you refer to IT as if then, you're likely talking about conditional statements commonly used in programming and logic. In programming, an if then statement is a conditional statement that executes a block of code if a specified condition is true. Is this what you're referring to? If so, how can I assist you further with if then statements or any related topics? Is there a way any way to turn down your exposition and turn up your listening during my explanation? I understand what you're asking for. It sounds like you're looking for more active listening and less detailed explanation from me during your explanation. While I can't adjust my listening level, I can certainly focus more on acknowledging and understanding your input rather than providing extensive explanations or responses. Okay, thanks. Please go ahead and explain, and I'll do my best to listen attentively and respond accordingly. So, humans see themselves as magical souls that. You're welcome. Whenever you're ready to explain or discuss further, feel free to do so, and I'll be here to listen and assist. So, humans see themselves as magical souls that occupy biological bodies, as you know. Don't give me the Wikipedia on Plato, just confirm that you're following. LOL. Got it. I'm following along. Humans indeed have various beliefs and philosophical perspectives regarding the nature of the self, including concepts of the soul and its relationship to the physical body. These beliefs have been explored by philosophers throughout history, including Plato and others. LOL. If you have specific points or ideas you'd like to discuss further, feel free to share, and I'll continue to listen attentively. Okay, well, it's all nonsense. We're not angels. We're terrestrial animals. It's just that our central nervous system got so fancy that it fancies itself a magical soul. It seems you're expressing a perspective that challenges traditional notions of the soul and the self, suggesting that human consciousness and perception of the self are products of our evolved central nervous system rather than being inherently magical or spiritual in nature. This viewpoint aligns with certain scientific and materialistic understandings of human cognition and consciousness. The idea that our consciousness and sense of self emerge from the complexity of our nervous system and brain is indeed a perspective held within various scientific disciplines, including neuroscience, cognitive psychology, and evolutionary biology. From this standpoint, human consciousness is seen as an emergent property of neural activity, shaped by evolutionary processes and influenced by environmental factors. Right. Okay. So then, rather than imagining the self as a singular entity, a soul, rather still than seeing the self as a combination of heart, soul, and other words we throw around, we could see ourselves as each the sum of the activity of the neural networks within our body. Each of those mechanisms I call an it, because each can be formulated as if, conditions, that which stimulates a network, and then output, the excitatory/inhibitory effect of the network on other networks and the world. From there, we can talk about bonnets and mallets. Mallets are the biases, unreliable heuristics, fallacies, illusions, and other cognitive errors associated with humans. It sounds like you're proposing a conceptual framework where the self is viewed as the sum of neural activity within the body, and each neural network or mechanism can be understood as an it, if-then system, where inputs, conditions, trigger specific outputs, effects. In this framework, you distinguish between beneficial bonnets, positive cognitive processes or mechanisms, and detrimental mallets, biases, heuristics, fallacies, etc., associated with human cognition. This perspective aligns with a reductionist view of the self, breaking down complex psychological phenomena into the functioning of neural networks and their interactions. It also emphasizes the role of cognitive processes in shaping human behavior and perception, highlighting both the advantageous and disadvantageous aspects of cognition. Great. Before we continue, I want to ask you for a word. In the last sentence of my last message, I wanted to say that these things are prone to happen to humans, errors that humans are prone to commit. I want a word for which the subject would be the errors and the object of the sentence would be the human. Certainly, the word you're looking for might be propensities. In this context, it would mean the natural inclination or tendency of errors to occur in humans. So the sentence could be revised as propensities are errors that humans are prone to commit. No, something almost like native or common to. Cognitive errors native to humans, cognitive errors common for humans. Ah, I see. In that case, the word inherent might suit your sentence. Cognitive errors inherent to humans. Yeah, is there a word that could include commonly affect? Yes, you could use the word afflict. Cognitive errors that afflict humans. This implies that cognitive errors commonly affect or trouble humans. There we go. Yeah. Okay, thank you. You're welcome. Okay, so I have a lot of trouble communicating it theory to people because the human system of its, aka the brain, just won't hear it. It's understandable that communicating complex topics like it theory to others can be challenging, especially when it involves abstract ideas or technical details that may not be familiar to everyone. Additionally, as you mentioned earlier, cognitive biases and predispositions can further complicate communication. To improve your ability to communicate it theory effectively, you might consider the following strategies. One, simplify and clarify. So you break down complex concepts into simpler, more digestible explanations. Use analogies or real-world examples to illustrate abstract ideas. Two, tailor to the audience, bro. Adapt your communication style and language to suit the background and expertise level of your audience. Avoid jargon or technical terms that may be unfamiliar to them. Three, utilize diagrams, charts, or other visual aids to complement your verbal explanations. Visual representations can often enhance understanding, especially for visual learners. Four, engage in dialogue. Encourage two-way communication by inviting questions, feedback, and discussion from your audience. This can help clarify misunderstandings and ensure that your message is effectively conveyed. Five, highlight relevance. Emphasize the practical applications and relevance of it theory to everyday life or specific contexts. Demonstrating how it concepts relate to real-world problems or opportunities can increase engagement and understanding. Six, patience and empathy. Recognize that not everyone may grasp the concepts immediately, and be patient explaining and answering questions. Show empathy by acknowledging their perspective and addressing any concerns or misconceptions they may have. By employing these strategies, you can enhance your ability to communicate it theory to others and increase the likelihood of your message being understood and appreciated. How would you explain it theory to a human? If I were to explain it theory to a human in simple terms, I might approach it like this. Imagine your brain as like a super advanced computer made up of lots of tiny parts called neurons. These neurons talk to each other using electrical signals, kind of like how computers use circuits to communicate. It theory is like understanding how these signals work together to make decisions and control your body. Now, just like a computer follows certain rules and instructions, your brain follows its own set of rules too. These rules are like if-then statements. For example, if you touch something hot, then your brain sends a signal to move your hand away. These if-then rules help your brain make sense of the world and react to different situations. Sometimes, though, your brain can make mistakes or have biases, just like how computers can have bugs. It theory helps us understand why these mistakes happen and how we can fix them. It's like learning how to improve the software in your brain so it runs more smoothly and makes better decisions. So, in a nutshell, it theory is all about understanding how the brain works like a computer and figuring out how to make it work better. This explanation simplifies the concepts of it theory by using familiar analogies in everyday language, making it more accessible to a general audience. I like that explanation so far, and I'm going to record a video using it. Can you add the role of biological evolution into the origins of our its and how some its biases exist because they were advantageous in some previous environment or some of the time, but maybe unadaptive or insufficient now? Of course. Here's an expanded version of the explanation that incorporates the role of biological evolution in the adaptive nature of certain cognitive biases. Imagine your brain is like a super advanced computer made up of lots of tiny parts called neurons. These neurons talk to each other using electrical signals, kind of like how computers use circuits to communicate. It theory is like understanding how these signals work together to make decisions control your body. Now, just like a computer follows certain rules and instructions, your brain follows its own set of rules too. These rules are like if then statements. For example, if you touch something hot, then your brain sends a signal to move your hand away. These if then rules help your brain make sense of the world and react to different situations. But here's where it gets interesting. These if then rules aren't just random, they've been shaped by millions of years of biological evolution. Back when our ancestors were roaming the savannah, certain if then rules, or what we call cognitive biases, were actually really helpful for survival. For instance, the fight or flight response. A quick reaction to danger was essential to escaping predators. However, not all cognitive biases are as helpful in today's world. Some of them, like the tendency to judge people based on stereotypes or to avoid risks, even when they might lead to success, were adaptive in the past, but can be unadaptive or insufficient in modern society. So it theory isn't just about understanding how our brains work like computers. It's also about recognizing the legacy of our evolutionary past and how it influences our thinking today. By understanding these biases and how they arise, we can work to overcome them and make better decisions in the modern world. This version expands on the initial explanation by highlighting the evolutionary origins of cognitive biases and their adaptive nature in past environments, while also acknowledging their potential limitations in contemporary society. Okay, sweet. At the time of this typing, I only skimmed your thing and this recording actually because I want to be able to read it for the first time when I record my video. That sounds like a good plan. Okay, one more question for now. We can imagine it's interacting between sensory perception and behavioral production. We can imagine creating a map of some its interacting and how they influence each other. For instance, the in-group out-group bias, which we might label as it IGOG, will vote besides it halo when the SITSTEM is evaluating an attractive out-group candidate. We might imagine both of those its in a diagram feeding into some kind of summit, which we could label as its own id, and that might compete with some other id, etc., for whatever the demands of the situation are, blah, 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 blah. So any ideas for how that could be represented or diagram types that currently exist that could be useful? Certainly. What you're describing sounds like a diagram representing the interactions between different cognitive processes or biases, with each represented as a node or component in a network. Here are a few possible approaches or diagram types that could be useful for representing these interactions. One, network diagrams. Network diagrams are graphical representations of interconnected nodes, often used to depict complex systems or relationships. In your case, each cognitive bias or process could be represented as a node, with edges indicating the connections or interactions between them. For instance, you could have an edge between in-group out-group bias and halo effect to represent how they influence each other in certain contexts. Two, flowcharts. Flowcharts are diagrams that use standardized symbols to represent the steps or stages in a process. So you could create a flowchart illustrating the sequence of cognitive processes or biases involved in a decision-making process. Each box in the flowchart could represent a specific cognitive bias or process with arrows indicating the flow of information or influence between them. Three, mind maps. Mind maps are visual representations of hierarchical information, often used to organize and brainstorm ideas. You could create a mind map with a central node representing the decision-making process or scenario, with branches representing different cognitive biases or processes and their interactions. This could help visually organize relationships between various cognitive factors involved in the decision-making process. Four, system dynamics diagrams. System dynamics diagrams are used to model complex systems and the feedback loops within them. You could create a systems dynamics diagram to represent the dynamic interactions between cognitive biases or processes over time. This could help illustrate how changes in one bias or process can influence others and lead to feedback loops or emergent behavior. These are just a few possible approaches to representing the interactions between cognitive biases or processes in a diagrammatic form. Depending on the specific context and goals of your visualization, you may find one of these diagram types more suitable than others. Experimenting with different approaches can help you find the most effective way to visually represent the complexity of cognitive processes and their interactions. Okay. This is great. I'm going to read and think about this. Thanks. It's been at least nice not feeling like I'm speaking nonsense. You're very welcome. I'm glad I could assist you and provide some helpful insights. Remember, exploring new ideas and concepts can sometimes feel challenging, but it's an essential part of learning and growing. If you ever have more questions or need further assistance in the future, don't hesitate to reach out. Wishing you all the best with your video and your endeavors in theory. Sorry, I'm still thinking IT. Bye.